Hi everyone, this is Remy, and this video is going to cover the Math 124 note outline for section 1.3, which is linear functions, slope, and applications. So we're going to talk about the linear function first, and we've talked about functions in a previous section. This is a specific type of function that when you graph it, it creates a line. So this is a function that can be written as f of x equals mx plus b, where m and b are constants. So that's saying m and b are fixed numbers, and then x is the variable. So if you have a function in this form and then you try to graph it, it would create a line. And then two subcases here. If the number m is 0, well, if we plugged in 0 here, that means it would just be f of x equals some number, and that is called a constant function. So you'll see that sometimes. And then if m equals 1 and b equals 0, well then 1 would be here, 0 would be here, so we'd get f of x equals just x. So then the function is f of x equals x, and then this has a special name. That's called the identity function, and we'll talk about that at the bottom of this page. So next thing I'll talk about is the slope of a line, and slope just means how steep is the line. It's often thought of as rise over run, and it represents the rate of change of y with respect to x. So another name for the rate of change is the slope. And then we have a formula to give us the slope of a line. And we usually call the slope m. So if we know that a line has 2 points, say x1, y1, and also x2, y2, then the slope formula comes from the fact that we think of m as rise over run. Well, the rise, that's vertical. Rise is up and down, which has to do with the y values. So for the numerator, we subtract the y values, y2 minus y1, over run means how far is it running horizontally left to right. So run has to do with the x values. So for the denominator, we subtract the x values, x2 minus x1. And this is our actual formula that we would use to find the slope if we know specific points that are on the line. So let's use this formula in this next example. Find the slope of a line that has the points 2, -4, and -7, 6. For now, I'll just call this one x1, y1, and this one x2, y2. But if you did it the other way around, you'll get the same answer. So let's write down the formula. So slope is the difference of the y's over the difference of the x's. And then we'll just plug in the numbers. So y2 minus y1, so that's going to be 6 minus -4 in parentheses, over x2 minus x1. So we'd start with -7 minus 2. And then we will simplify. So m equals, in the top, 6 minus -4 is 10, and -7 minus 2 is -9. So that's our slope. We have a positive number on top and a negative number in the bottom. and it's better to just move that negative up to the top, either up to the top or out in front. So something like this, m equals negative 10 over 9. But this one tells you that from one point to another in the line, the top deals with up and down, so this is telling us to go down 10, and then the bottom tells you go left or right, and since it's positive, we'd go right 9. So if you had a line with these 2 points on it, then the slope of that line is negative 10 over 9. Alright, now let's talk about the identity function. So we said that this is f of x equals x, or using old notation, maybe y equals x, because remember, f of x is the same thing as y. Let's create a chart to figure out what some of the points would be on this line. So let's plug in values for x. The standard ones to usually start with are these numbers, negative 3, negative 2, negative 1, 0, 1, 2, 3. Well, if we plug in negative 3 for x, it spits out negative 3 for y because they're equal. So I'd have negative 3. If I plug in negative 2 for x, I'm going to get negative 2 for y because they're equal. So the x values are always going to be equal to the y values. So these are all our points. And if I plotted them, I'm going to label my axes, put in a scale 1, 2, 3, 1, 2, 3. Alright, and then I need to plot negative 3, negative 3, negative 2, negative 2, negative 1, 0, 0, 1, 1, 2, 2, 3, 3, and so on. So we see that the line that's being created is a perfect diagonal line. Like that. So this function looks like this, and so you should have this one memorized. That f of x equals x, the graph looks just like that, a perfect diagonal. And then let's also discuss the slope of this line. Well, we know that the slope is rise over run. So we choose 2 points. It doesn't matter which 2 points you choose. So I'm just going to choose this point here and this point here and see what the rise and the run are between these 2 points. So always go left to right when you're finding the slope on a graph. So if I'm going to start at this point and go to the right to this point. So from here to here, it rises, it goes up 1, 2 times. Over, the run means how far is it going left to right, but we're going to go from left to right. So it runs, once we go up 2, we have to go to the right 2, and that's the run. So from here to here, it rises positive 2 and then runs positive 2, and that reduces to 1. So this is the slope of the identity function. So that was just to demonstrate the different properties of the identity function. All right, let's go on to the top of page 2. All right, we're going to talk about horizontal lines and vertical lines. So if a function is a constant function, meaning it's in the form f of x equals b or y equals b, then it's going to produce the graph of a horizontal line. And these are functions. And then for a vertical line, an equation would have to be in the form x equals some number. So a would be a constant, and then up here, both these numbers, the b's, are constants. So that's just saying that f of x is some number, or y equals some fixed number. Down here, x equals some fixed number. So for the vertical line, if it's in the form x equals a, then it's going to produce the graph of a vertical line. And in that case, if we ever have a vertical line, it's not a function. So let's do an example of each of these. So let's first talk about a constant function. So it would have to be in this form. And I'm going to use y. So let's say, for instance, we have y equals -4. So it's in this form. It's just y equals a number. So let's graph it. Here's my x-axis. Here's my y-axis. I'm going to go by ones and by ones. And this one is saying that the y value is always equal to -4. So here's -4. At this point, the y value is -4. Even at this point, the y value is -4. Over here, the y value is -4. And here, and here, and here, and here, and here. Everywhere that I'm drawing right now, the y value is -4. And so that means that this is the graph of that equation. So you can see it produced a horizontal line, because no matter where you are on this line, the y value is -4. And then let's do a vertical line. So for a vertical line, it has to be in the form x equals some number. So let's do x equals 2. So I got my x-axis, my y-axis. I'll go by ones. And this time, we have to think about where do we have points where the x value is 2. Well, x is horizontal, so this is 1, and here's 2 right here. So at this point, if you ask yourself what the x value is, you're going to get 2. And same thing here. This is the point 2, 5, so x is 2 there. Down here, this is the point 2, -5, so x is 2 here. X is 2 here, and here, and here, and here, and here, and so on. So this time, I'm getting a vertical line like that, because no matter where you are on this line, the x value is always 2. So we see if it's in this form, y equals a number, we'll get a horizontal line. And if it's the form x equals a number, we'll get a vertical line. And then let's talk about one more thing on these graphs. Let's talk about the slope of each of these lines. So let's start over here. So for this one, we want to find rise over run. So just like before, I'm going to choose 2 points. It does not matter which points I choose. So I'm going to choose this point here, and let's go with this point here. And when we're finding the slope from using a graph, we always go left to right. So I'm going to start here. From this point over to this point, how much is it rising? How much is it going up or down? Well, it's not going up or down. So the rise is 0 over the run means how far is it going right or left? Well, from here to here it's going 1, 2, 3, 4 values to the right. So that was a positive 4. And so 0 over 4 is just 0. And what this is telling us is the slope of any horizontal line is 0. Now let's do the same thing for this line. The slope is rise over run, and we're going to choose 2 points. Doesn't matter which two. Let's choose this one and this one. So from one point to another, let's say this point to this point, how much is it rising? Well, it's going down 3. So I'm going to write minus 3. 1, 2, 3. And then for the run, from this point to this point, how much is it changing left to right? Well, it's not going anywhere left to right because it's going straight down, so the run is 0. And then now looking at this should set alarm bells off in your head because we are never allowed to have 0 in the denominator. So this is undefined. So M is undefined. And this is true for any vertical line. So in summary, the slope of any horizontal line is going to be 0, and the slope of any vertical line is undefined. All right, now let's graph a line that's not horizontal or vertical. So let's graph the function f of x equals negative 2/3 x plus 1. And then we're also going to find out what the slope is. So at this point, we don't have any other way to graph a line other than to plot points. So let's plot some points. And let's choose some nice numbers to plug in for x. Well, 0 is always a nice number to plug in. If I plug in 0 for x, this term goes away entirely and I get plus 1, so it spits out 1. And then other nice points that I could plug in would be multiples of 3, because I see a 3 in the denominator, and so that will make the values cancel out nicely. So I'm going to plug in negative 3 and positive 3. If I plug in negative 3 for x, I have a negative times a negative, so the entire thing will be positive, and then the 3's will cancel, so then I get 2 plus 1, which is 3. And then if I plug in a positive 3, I plug a 3 in here, the 3's cancel, I'm left with negative 2 plus 1, which is negative 1. So let's plot these values. So I have x and y, and let's go by ones. Okay, I'm going to plot negative 3, 3. 1, 2, 3, 1, 2, 3. There's my first point. I'm going to plot 0, 1, which is here. And then I'm going to plot 3, negative 1, which is here. And it looks like I'm on the right track because if I connect these, I do get a nice straight line. And I know that this should be a line because it's in the form y equals mx plus b. So another way to name y again is f of x. So you could rewrite this as f of x as well. So we graphed it, we're done with that part, and then we also need to determine the slope. So I'm just going to do that using the picture. I'm going to choose 2 points. So I'll choose this point here and this point here. So slope is rise over run. So I'm going to go from here to here, left to right. So how far is it rising from here to here? Well, it's going down 2. So I'm going to put -2 because it's going down 2. And then it's going to the right 1, 2, 3 times. So the run is +3. So this is our slope, -2 over 3. Okay, let's go on to the top of page 3.